um, and the kind of the good news is, all right, if you wanted a little bit of good news about tonight and this week, is as far as I am concerned, tonight is, this week is perhaps one of the easier, got some people I need to let into class here. Yeah. Tonight, this week, it may be one of the easier weeks of the whole quarter. So hopefully that doesn't, hopefully you'll find that to be true, okay? The concepts are really not too complex, and just a matter of taking some good notes and then going over those notes before the next exam. So, all right. So the first concept tonight I want to talk about is the mean or the average, okay? Hopefully you've heard this before in a good science class. They talk about it all the time, the mean, the median, and the mode. But this word, the mean, just means the average of a group of numbers, okay? So whenever you hear that from now on in chapter 1.8 of your textbook, it has to do with finding averages, basically, finding the mean, okay? And there's a very simple formula, which many have probably been exposed to before, but it's step 1, add up all the numbers. Step 2, divide by the number of numbers, okay? The number of numbers. And that will give you your average. And you'll do that on your calculator. So this will be a piece of cake, popping through some of this stuff. Even when you have longer numbers, these, 17,341, and, like 4 other numbers that are pretty big, punch them all in, add them all together, divide by how many numbers you got, and there's your average, your mean, okay? So for example, in example A, if they said, hey, find the average of 2, 4, and 6, okay? Step 1 is to add them all up. 2 plus 4 plus 6 is 12. Step 2 is divide by how many numbers are there? Uno, dos, tres. So you divide by 3, you get the answer of 4. Example B, find the mean of 6, 8, and 12. Add those numbers together first, get 24. There's only 3 numbers. Divide by 3, you get 8, okay? So that's some simplified version of how you find the average. You're just adding them up, all the numbers, dividing by how many numbers there are, okay? Give you a moment to copy down what's on this slide, if you don't mind. Resume recording. Okay, we're looking at this example in the bottom of the page. You're trying to find the mean, which is the average of 10,000, 11,530, 11,006, and 19,122. Punch them each one separately in your calculator using the plus sign each time. Press enter, get an answer, divide by, looks like there's 4 numbers. There's your mean, okay? Your median number is your number in the middle. And so I would look at these numbers and put them in order from smallest to biggest. So in this case, I would do 10,000. And then the next smallest number is 11,006. And then I've got 11,000, wow, nice 11 there, 530. And then I've got 19,122. Okay, so in this case, if I'm asked to find the median, the middle, I'm now going to take these 2 numbers, add them together and divide them by 2, and that gives me the median. So again, in fast review here, okay, to find the mean, we add up all the numbers, divide them by how many numbers. To find the median, we place all the numbers in the order from smallest to largest, and then choose the middle number, like in example A here. However, if there are an even amount of numbers, first place all the numbers in order from smallest to greatest, circle the middle two numbers and divide that by 2, and that will give you the median. And then finally, the most often, the mode is just the number that occurs the most times in a set of numbers. And again, sometimes it could be more than one. In example B, both 7 and 2 occur more than once, just twice actually. So, all right, this is kind of like the one challenging part of this whole chapter here. And the good news is there are not a lot of problems asking you for your homework to figure this out. However, there is one, and that's why I wanted to kind of give you the kind of the heads up here and try to make some heads or tails of this. It's the idea of the midpoint of a line here. So for instance, if I had a line segment going like this, okay, and they ask me, what is this? What's the midpoint? Okay, what they're asking me for is what are the actual coordinates of this middle of the point? That's the midpoint. That's what they mean by the midpoint of a line segment. Okay, what is that middle? All right. Now the middle is kind of like finding the middle number like we just were before, right? But now they're kind of, moving it over and applying it to like a graph. How would you find the middle? And so here's our magic formula for finding the middle of a line. You've got 2 points on a line. The formula is, which you'll want to write down here, A plus C over 2, which is divided by 2. That's your first coordinate. Okay, that's going to be your x coordinate. And then the second coordinate is B plus D over 2. Okay. So it might be helpful if I just kind of added underneath that, you kind of added this in your notes here. If I took, our coordinates here, I've got, you see over here, I've got coordinates -3, 9, and then in 2, -5. So here, I'm just going to write it down kind of close to the formula so it kind of makes some sense here. I've got -3, 9, and the other coordinate is 2, -5, okay? So if I wanted to label those, what are those according to my formula, A plus B plus C, okay? Well, let me just write little letters above them, and you might as well do this in your notes here. This is A, this is B, this is C, and this is D, okay? You're just lettering them straight across, okay? A, B, C, and D. All right. Knowing that now, if the formula for the midpoint is A plus C, well, A in my numbers is -3 and C is 2, right? So if I take a -2, -3 plus 2 and divide it by 2, I get -3 plus 2 is -1/2. Okay, you'll notice I wrote -1/2 here. So the x coordinate that is the midpoint, part of the midpoint answer, this is the x point. Okay, I'm afraid to even write x above it because I don't want to confuse you with more letters. Okay, now if that's the x point, how do I find the y point? It says b plus d over 2. Well, b is 9. Here, back over here, b is 9 plus d. D is -5. So 9 plus -5 divided by 2. Okay. Hopefully what you're seeing here, and this will help your eyes and your mind to understand this, is that all these letters here just stand for the letter of the coordinate. Okay. And just use the one that matches up with it. So 9 plus -5 is 4 over 2, and 4 over 2 equals 2. That's my y coordinate. So my answer, okay, my midpoint would be as an answer, okay, would be as an answer. Let me just choose red here. Maybe it'll stand out a little bit. My answer for what is the midpoint between these two coordinates here is -1/2, comma 2. Those are the coordinates of the midpoint, okay? In a sense, -1/2 and around here, it's about right here on my graph. So if I wrote it here, -1/2, comma 2, all right? Hopefully that's sort of making sense to you, that you're just going to follow this formula and that the letters stand for, just take the coordinates that they give you and plug them in right here. The first coordinate is right here. The second coordinate is right here, okay? Plug it into the formula and you'll get 2 answers, and now you've got the x and the y of the midpoint. All right, now this is where it gets a little tricky in one of your homework questions, okay? So I wanted to give you the heads up here tonight. One of your homework questions on this is, it's going to ask you, it's going to give you this coordinate right here and the midpoint coordinate. And it's going to ask you, what's the endpoint coordinate? What's the missing, what would be the end coordinate? Okay. That's a bit of a curveball, but here's how you figure it out. You're going to have to use your brain on this, but you're going to take the A, okay, A plus, in this case, C, you've got A plus C. Well, C is this part of this coordinate right here. It's this one right here, okay? There's 2 here. You're not going to have this. So what you're going to write down is, I'll write it down here, A plus, we don't know what this is, X divided by, if you just want to write this down, by 2 will equal, this is the magic here for figuring this out, okay? Trying to figure out what this X is. Let's say this X was -3, okay? In this case, like it is in the example here, okay? We got to figure out, okay, because they're going to give you the mid coordinates. So you'll know what the answer is supposed to be right here. You'll know this answer right here because they give you the first and the second coordinates, okay? And the first coordinate is supposed to be right here, okay? So what you now figure out is -3 plus what equals the answer they just gave you, okay? Because that's the A plus, it's supposed to be the C here. We don't know what C is, but what is it that I add to the -3 that will give me that answer they've already given me by giving me the first coordinate of the midpoint? Once we figure that out, how that solves that equation, I now know what the first coordinate of the endpoint is. And I can do the same thing for the next one. I'm going to plug this part of the formula in and go B, which in this case would be 9, plus D, which we don't know. So I would say 9 plus X divided by 2 equals, and guess what it's going to equal? It's going to equal that second coordinate in the midpoint. They gave you the answer here. They gave you the midpoint coordinate. So whatever the Y number is, plug it in here, okay? and then figure out what 9 plus x divided by 2, what makes it equal 9. And once you figure that out, whatever 9 plus x divided by 2 equals whatever this number is, you now know what the second coordinate is. Okay, so spent a lot of time on that, but that is kind of my extra help for that homework question. I hope it goes smoother. Okay. All right, I want you to take a moment here and copy down this first slide here. All right, so in chapter 1.9, its focus is just giving you a kind of an introduction to the different kinds of charts and graphs, some of them that you often see in math and science. And if you've ever wondered, you know, how come they're using a pie chart this time and a line chart that time? What's the difference? Well, tonight, maybe for the first time in your life, you'll get a little bit of clarity on the difference and why it's when it's best to use each type of chart. Okay, for like this will help you in presentations for school or business. Well, for example, let's look at the first type is a pie chart. It gets its name because it looks like a pie. In fact, all of the types of charts that we're going to look at both this week and then we'll look at scatter plots next week, they're all named for what they look like. Okay, so a pie chart looks like a pie. It's shaped like a pie. It's got pieces of the pie. Now, it's really important that you understand a couple of concepts though. Pie charts are best, you really want to underline this, for comparing a part to the whole. Okay, that is key, both in business when you're trying to make a visual aid and want something to really stand out clearly. How much we're spending on our budget on gas compared to the rest of our budget. If our business is, doing a certain amount of things, and we want to know which one's really not helping or something. Sometimes a pie chart's perfect because, let me finish my little notes here. You always want to express the answer in a pie chart, usually always as a percent, like you'll see here, 20% of favorite types of movie, 20% of them like sci-fi movies and 5% like dramas and 30 romance and comedies, 20 and 25 action adventure. Okay. So pie charts are expressed as a percent, which kind of makes sense because you're talking about a percent of the whole, okay, of the whole amount here. So I guess I've had better nights for drawing circles, but anyway, but they're expressing a percent, a part of that whole, okay? And they're usually, again, expressed as the answers as percents. Now, for your own advice, and really in any well-done publication, you want to keep the quantity of slices relatively small. And here's why. Because if you have 30 different slices, it starts becoming really hard to tell how they compare to all their other slices. I'm reminded when I grew up in Bellevue and went to Sammamish High School and graduated in 1978, but I came back and visited the school as a teacher in the last 10 years. And now it's considered perhaps the most ethnically diverse school in the entire maybe world, because there's people from all over the world that live in that area around Sammamish. And so they showed us a pie chart of all the various nations and what percent of our students at Sammamish High School came from these various places. And there's like 60 nations represented. And it was fascinating to see that they were from all over the world, the students were. But if you ask me, what are kind of the dominant trends, like what are there most of, it becomes a lot harder to figure that out, the part compared to the whole, because they all kind of they're all the same size and the slices were, okay? So that's why if you're giving a presentation, try not to have a whole bunch of categories, you know, maybe 5 or 6. 1, 2, 3, 4, 5. You see how 5 just kind of looks kind of clean here. All right. Next one, and again, I'll give you a moment or two to copy this, are bar graphs. Hopefully you've had a chance to sketch out a rough version of a bar graph here. Key concept of the bar graphs, okay. Excuse me, they're best for comparing the part, and this is the key concept right here again, to a part, not to the whole now, to another part. Bar graphs are really good at this, okay? I'll tell you what I mean. Let's see here. So let's say we're asking people in a survey their favorite sport, okay? And this is soccer, okay? And you got basketball, tennis, hockey, and baseball, okay? The reason why this is nice to use a bar graph in this case is I can now look at the parts really easily and see how they compare to the other parts. For instance, I can look at soccer right away and know that it's the most preferred sport compared to all the other parts. I can look at hockey and know it scored the lowest compared to all the other parts, okay? I could look at basketball and baseball and say, you know, they're pretty close compared to this part to that part, okay? So again, that's why bar graphs are used often, is to show how. Another example you might see in your homework is they might give you a bar graph of a community, of a city's community colleges. All the community colleges, it might list 7 community colleges and give how many students go to each one, and use the bar graph to show which community college has the most students compared to the other parts, the other community colleges, or which community college has the fewest students compared to the other parts, the other community colleges, okay? So that's a little bit about when and how to use a bar graph. And here's just another example. Please don't feel like you have to copy all this down, but the most bought fruit, okay? And looking at my number of fruits and everything, I can look right away and go, okay, this bar graphs is real nice because it shows me right away that oranges is number 1, watermelons is last, okay, in the most purchased types of fruit. And it shows me how they each compare to all the other parts in the graph. All right. I think this is about it, the last one for tonight. So go ahead and take a moment and copy this slide in your notes. So the key concept for line graphs, folks, is understanding that they're best for showing change over time. And then they also use what's called pair data, like, you know, the x and the y axis, 2 over and 10 up, that's what they call paired data, where you have like 2, 10, okay? And there's your x-axis and your y-axis, and anyway, that's what they call paired data. You're pairing your x paired up with the y. All right, in this example, here's what I mean by change over time. If you look down at my chart here, it says at the top, facts I got correct. So while I'm studying for a test or trying to get ready for an exam I have to pass at work in order to get the next pay level or something, or so I'm practicing on my own at home, okay? And the y-axis represents the amount of facts I'm starting to get right. After the first day, I got 3 facts right. I'm studying, okay? After day 2, didn't make a big improvement, okay? I improved by 1 fact, but I kept studying, and from day 2 to day 3, I jumped up to 12 facts. So basically, I tripled my amount of facts I needed to pass that test. And after 4 days of studying, I had 15 facts in my head. And let's say that's how many I needed to pass the test. And I felt like, okay, I'm ready. This graph shows that over time, day 1 through 4 here, the change that took place. And you'll notice again, just like its name, it's called a line graph. The graph is laid out in lines. Now, and why are there lines? Because you're going from one data point to the next pair of data, to the next pair of data, to the next pair of data. And that creates a line, okay? So again, those types of line graphs show change over time, most simply. That's where they're most helpful. I want you to take a moment and just look at this one. Please don't feel like you have to copy this down. But I'm going to ask you this question. Here's the question. What 2 types of animals do we need to be most concerned about based upon the change over time from 2017 to 2022? What are the 2 types of animals we should be the most concerned about? Let you think, look at the chart. Blue is for bears, orange is for dolphins, and gray is for whales. Okay. All right. I'm going to help you out here. Okay. First of all, if I'm concerned about wildlife population, I probably want to be concerned about, is there one of them that's declining a lot, or we're losing a lot of them? And yet dolphins seems to be the one here. We started in 2017, and whatever area we were watching, we had about 150 dolphins. But by 2022, that went down to essentially 0. Something really bad is happening in our area to dolphins. So we're going to be first and foremost worried about what are we doing wrong in our ocean to the dolphin population. Okay. Now I'm just going to tell you my choice for the other one I would be concerned about. Okay. And that is, trick question here, bears. Okay. This is kind of a speculative reason why, but I noticed that in 2017 in this area, let's say it's, I don't know if I want to guess an area, say it's around Florida or something. We had 5 bears, but by 2022, we had over 180 of these bears. Here's why I might want to be concerned about that. Because at the present rate of growth, we're going to reach a point somewhere along the line out here where we're going to have a lot of bears roaming around and nothing that hunts them. And they're going to be attacking farmers' cows and all kinds of things. So you see how this line graph is kind of helpful. It shows over this period of time that, hey, dolphins went down to almost extinction. Bears are really growing here, okay, over time. And so thus line graphs, real helpful looking at something over time, its change over time. All right, let me do this. Let me stop my recording if I can figure that out.